Welcome back. Welcome back. We just set up my mic. So we're going to be doing this question. Convert sorted array into binary search tree. Given a number, given an integer array nums where the elements are sorted in ascending order, convert it to a height balanced binary search tree. I don't know how to fucking do that. Alright, so looks like they just find the smallest number. Num's dot length is 1, so there's at least one node. Num sorted strictly increasing order. Okay. Okay, so let's just use resources to figure this out. So how do I define the root node first? I think that's the biggest thing. So first I have to figure out what the root node is, then I can figure out what the rest of this shit is. Okay, so input, output. Input, output. So I mean, do I get the smallest number first and then just work my way from there? I think that's the way to recurse through. It's got to you have to figure out some root node, and then you have to do a callback on itself until it just adds a bunch of nodes to either the left or the right side. Node.left or node.right. So I think the trick is finding the root node. I'll take a crack at it. Strictly increasing. Nums is sorted in strictly increasing order. Oh, if it's strictly increasing, that means the first element is the smallest. And then there's got to be swaps or something. Let's try. Let's look at the pseudocode. So convert a list to a sorted binary search tree. Finds position of middle element to linked list. Okay, so let's look at the pseudocode. Let's look at the pseudo fucking code. Okay. Sorted array to balanced BST. Given sorted array. Set the middle element of the array as the root. Recursively do the same for the left and the right half. Oh, I'm basically creating a binary tree. So first I gotta find the midpoint, so it's gonna be nums. Mid equals nums. Floor 2. So that floors it down to the middle. So then I also got to get the length of the left and the right. Recursively do the same. So sorted array int, what is there here? Sorted array int, okay, and start end. This just gives me the nums array start and end. This is in C++. Where's the Python? Yeah, so min is the length of the array divided by 2. So nums, length of the nums divided by 2. So I got the midpoint. If not array, return none. So I guess because we're doing I guess since we're doing what's it called? Recursion, you need a base case. So if array equals none, then it's thing. So then I have to find my left. So root node. Okay, so we have to create the root node. Roots equals node mid. Tree node. So basically getting the node out left equals yeah, if you know the concept of it, then it's easy because it's just like, okay, I know what to recurse, right? So if it's nodes, I want to find the midpoint of the node. So basically it's the opposite of how you'd actually search for elements and remove elements. Now you're like adding elements to the tree. So basically I have a sorted array, I get the midpoint. If the array is none, if the array is no longer a thing, if it's or doesn't exist anymore, return none. Node.left is sorted. We go to the midpoints. Node.right is sorted. Mid plus 1 to the end. Then I return the root. Yep, return the root. So basically this is it. mid. It's got a self element. Oh, mid is right now it's comparing, it's not assigning. It's not defined. Okay, so I have to call it on itself. Because I'm using within itself. Oh, this is root. Run. Root left, root right, sort. That's put new? No, I just put node. And this would be tree node. Oh, I took the value. Oh, sorted array to BST. Bro. Sometimes a lot of this is just working with the compiler and syntax. It's not even solving the problem, it's the hardest part. It's just the syntax. Okay, root.right. Okay, sorted array. Oh, fucking spell check. I'm crying right now. I'm crying right now. There we go, and then we submit it. Boom, beats 33.86. So basically what this does is the opposite of binary search. So when you want to find something, you have to go half, 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 then remove the node, right? This one, you're going to the opposite of half. You're going mid, 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 and then you're adding the node. So one, you're cutting it in half and removing the node. The other, you're cutting the array in half and adding the node. So it's going to be like, you find your root node. So you get your nums divided by 2, and then that base case return none basically tells you that it's over. So this root.left teleports to the end. So it goes left. It's going to be this, then sorted array nums to mid. Now it takes the left half again. Now it does the midpoint of that. Then it takes the left half again. Now it does the midpoint of that. And so on and so forth. And then it basically gets your whole left subtree into this root.left. The root.right is like, okay, now it goes to the right, takes takes the root node of that, then it goes to the right, takes the root node of that, then it goes to the right, takes the root node of that, and then until you hit none. Now you have your full left subtree, your full right subtree, and you just add it to your root, which you got here originally. It's gonna be root.left, root.right, and return the root because that gives you the entire tree, right? So that is how you recurse. So we're gonna break down now the way we recurse here. So this nums going to none is basically telling us that the array is over. The midpoint is length of the numbers divided by 2. These 2 slashes are floor. So if it's 2.5, it goes to 2. If it's 2, it goes to 2. If it's 3, it stays at 3. Right? But if it's 2.5, 2.7, 2.1, it always goes to 2. We're basically chopping off the decimal portion. Second, when we go to get midpoints, this is an array slice, which goes from 0 to mid. And that is inclusive. This goes up to the midpoint, which is why on the right side I start at mid plus 1. Right? I start at mid plus 1 because it's going to start at the mid plus 1 till the end. It goes to the end. So this is how you get your 2 subtrees, add it to your original node, and then return the entire tree back. Yeah, sure, we used a little bit of help. we searched up the algorithm for it, but like, not the algorithm, we searched up the pseudocode for it, and then we just implemented it on our own. Because, hey, like, you're not going to be able to remember everything, right? There's 1,000 questions on Leetcode, right? Are you gonna be able to remember 1,000 things for your interview? I can't. I can't remember 30, right? So like, as long as you understand the concept and why you're using what you're using, then it's okay to look at resources, right? So for example, if I looked at this and I didn't know how to solve it, and I just blindly put the code here, that's a problem, right? Because I don't know why I'm using what I'm using, right? So even this self dot thing, right, said it's not defined. So for example, let's say if I remove this, and I run it, it's going to say not defined. Not defined. See, it's because it doesn't know where the sorted array to BST is, because you're calling it within itself, right? So that's why you have to use self dot sorted array to BST. Then when you run it again, it works, because now it knows that it's taking it from itself. You're calling itself, using its own properties, using its own values, right? So yeah, we're gonna keep doing problems like this. We're gonna keep looking at resources. I'm just trying to show you that if you don't have the answer, you can get to the answer, right? You don't need to stare at a question for 3 weeks, right? Like, people will say you get the most reward out of solving the question yourself, and that's true. You do get your golden nugget, right? But do you have 6 weeks? Do you have 6 weeks to solve one easy question on Leetcode, right? That you're gonna take an hour every day and like get stuck and then look at then by the time you solve that one question, now there's another question. That's another 6 weeks, right? Or you could just do the smart thing, get your reps in, right? Do 30, 40 of these questions, right? But only spend 30 minutes looking at the initial solution to understand the concept, or look at the pseudocode, understand the concept. Now you can do this 50 times in a row, right? In like exponentially less time than you would if you were to solve it from scratch, right? So don't be fooled by this golden nugget of I have to do all the heavy lifting myself. A lot of people aren't doing that. They're taking the shortcut. They're being smart. They're using resources. They're using tools, and they're fixing their mistakes and their thought process and correcting as they go. The same way I'm doing it right here. So we're about like 20 something videos in. Watch me at 100 videos in. I'm gonna be just fucking straight to the target, you know? Like, I probably won't have to look up anything, and I'll probably make a better solution than what's on here, right? So that's just my rant, but I just want to make sure everyone here gets the maximum amount of value that you came for. I'm not here to waste your time or sugarcoat or give you some bullshit excuse as to what you should be doing. No, I'm just gonna say what works for me, and if that works for you too, that's great, because you found the right spot. All right. So with that, if you like the video, please give it a thumbs up. Please subscribe to the channel if you haven't already, and I'll be producing a bunch more of these. Let me know what you think in the comments. Knologist out.